Hey, look at that, I'm live. I think. Yes, I'm live. Nice. Okay, I have been up since very early in the morning, and I am ready to now do a research stream. Oh, good golly, Miss Molly. Okay, so what we're doing today is a secondary analysis for the turtle bioregions. What it is okay. Let's back up. Let me open up Notion really quick. Okay. So, oops, wrong Notion. If we go to my research, here we go. Turtle phyloregionization. Yeah, so I have been working on this project for a bit now. Turtles of the world trying to create phyloregions, right? And we did get some methods. We did get some results. I read the word methods. We did get results, right? We have these really cool phyloregions. Basically, areas of shared evolutionary history for the world's turtles. It's looking pretty good. I'm very happy with it. I want to add in something. I want to add in this methodology called Canopy. Canopy stands for Categorical Analysis of Neo and Paleo Endemism. And this is a really cool analysis that I am very excited for. I've run it a couple times on some other data sets, but just to kind of test it and figure it out. But now I think I can actually do it in a really good way. So I need some music to focus a little bit better. But let's talk about what all this is and why and how we're doing it and all of the good fun stuff. So, let's start off with endemism. Endemism is a concept. We've heard of endemic species before. Basically, endemism. Sorry, I'm trying to figure out some stuffs. Let's see. I wish I could keep. No, I don't want to put chat there. I wish I could keep chat on top. Maybe I do just keep it on top, and then I minus that out. No, I can't do that. I want to. Ah, well, whatever. Okay. There we go. Yeah, okay, there we go. So endemism is this concept that essentially refers to a species or even a group of species that is only found within a particular area. That's endemism. So an endemic species is only found in one area. Now, endemism is, of course, context specific. Every single species on Earth, well, except I guess ones that went to space. No, still. Every single species on Earth is endemic to Earth. Why? We're only found on Earth. What was I clicking on? Let's do Stone Rebel. Oh, you might be hearing that. Let me turn that off. Copyright. So, where that contrasts, though, where we learn more is about phylogenetic endemism. I'm going to look up a definition, though, because I am just really terrible with explaining this, which means that I need to understand it a little bit better. So phylogenetic endemism, it's where unique phylogenetic lineages are constrained to restricted geographic areas. So, for example, boa constrictors, they are endemic, phylogenetically endemic, to the Western Hemisphere. They're only found in like South America, North America, Central America. So that's really all it's saying. And phylogenetic endemism is a bit it's a bit confusing. I'll admit that. Like, how does that differ than regular endemism? Well, what we're able to do is we're able to take those branch lengths of a phylogeny, so how unique an organism is, how different it is from other organisms, and really showcase it better. So let's see if this paper has anything else about the phylogenetic aspect of it. Yep. There's metrics for determining endemism. Um, but this is not really giving me what I need. I just need the word phylogenetic. But yeah. Oh, here we go. Maybe just the paper that's talking about it. um, so it combines phylogenetic diversity with weighted endemism to identify areas where substantial components of phylogenetic diversity are restricted. These are typically better for conservation purposes, which is something that I'm really interested in. Now, there is this program called Biodiverse. It is awesome if you're doing anything related to spatial analyses of diversity. Biodiverse is 1,000,000% for you. I think I do have it on here already. I should have it. Oh gosh. Where? Oh, look at this. So I actually have a file called Canopy Biodiverse. Yeah. So this is one I ran for... Oh, I think this is all the grid cells of a different project. But what we see here is we have the element, which is the particular grid cell that was used, and it's calculated each one. So this one is phylogenetic endemism, weighted endemism. I forget what the P is. This is philo... Oh gosh, what is RPE again? Relative phylogenetic endemism, the differences, as well as the null. So this is like a null is they basically randomize the branches across the tree, and then it's compared to the actual. So it's like an estimate. And yeah, that's basically all it's doing. So what I need to do is I need to do this phylogenetic endemism for the world's turtles. So looking at these, and I'm going to do them in a couple different ways. So let's start writing this all out. So if I open up, not herp phylogeny, herp phyloregionalization, let's just open this as a page. Yeah, so let's add a new method. So here we go. Also, if you are interested in this Notion template that I'm using, I'm actually about to put it up on my website for free download. So Canopy. So, okay, categorical analysis of neo and paleo endemism. Yep. So let me now pull up. So when we're talking about this neo and paleo endemism, if you think about along a phylogeny, there's two patterns that we can really see. Let's say that we have maybe there's actually an example. So let's see if I can find a good example with a phylogeny included, but it's not really looking like... here we go. So a neo-endemic, it's a new endemic. This arises when there's recent speciation within a clade. So basically saying that within this branch that's up here, there's several species and they're endemic to an area. This is like recently they've speciated, but they haven't had the time to disperse to a larger landscape. That's neo-endemism. So they're restricted because they're speciating. Paleo-endemism are these longer branches, right? So this one is a paleo-endemic, this one's a paleo-endemic. There's methods that they use to calculate this, but typically this is showing that, hey, there might have been more species, but they went extinct. Or this is it's an older lineage, an older clade, but their range has now collapsed into a smaller area. So it can kind of show two different things. Mixed endemism is ones where it's kind of showing both within a region, that there's also neo-endemism as well as paleo-endemism. And those are really cool. There's also one called mixed. So, for example, this is a phylogenetic richness and endemism of California fauna. So you see areas with mixed endemism, which are usually purple. I think super endemics are these darker purple ones, which are a little bit hard to see. But yeah. So this is something that I'm really fascinated with, and I really like it. Yeah, so here's one of the critical papers of it. with Australian acacia. So new endemics, paleo endemics, mixed endemics, and super endemics. What I'm going to do is with these turtle phyloregions, again listed here, is I'm going to run this one for every region that I have, just to see what that would do, but also for every hydrobasin unit. So I'm going to do that just to see what's going on here, but I want to, the reason I'm doing it in two different regions is mainly because I want to see if there are individual phyloregions that highlight out, but also within hydrobasins, are there any of like really key concern? I'm not super sure if we'll get that much with the individual hydrobasins, so I want to be able to figure this out, but I need to do this in R. So let's, wow, hold on 1 second. I need an antacid. I am dying. So, I know I have notes about canopy somewhere, but no idea where. Because I don't think I have it in my Notion. Because they must have been notes I took a long time ago. Are they in this book? Not this book. Hold on. I might have them written down, actually, instead of typed out. Oop, that's what I do best. Fuck up everything. Okay, these are my general notes. This isn't it. This is where I had my money. Let's see here. My old notebooks. Very useful to have on hand in case Notion isn't working. But the problem is they are a pain in the ass to find anything. And my handwriting is fucking awful. Okay. Spitfire controversy, Jesus Christ. Oh, my notes for drawing up a fucking... Oh god, I got so much... Ooh, is this something? Azevedo, Pyron, PNC, blah 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 blah. Yeah. See, these are really tricky notes for me because I just have so many. So it's like really hard to find exactly what I need. And that's why I use Notion now. Because while this really helps me cement knowledge, it's just like kind of useless. It might be in this notebook instead, because this one was more catered, I thought. Oh, I think I'm wrong about that. This is actually my general notes, not... I mean, I know if I look through it, it'll re-click, but... I mean, it's nice to see this, know how far I've come, but ultimately, this doesn't help me out. Yep. Yeah, like all my notes. Like, all my handwritten notes. I'm so glad I moved away from this. Just because it's like stuff like now, it's like, oh, I've definitely taken those notes before. Where the fuck are they, though? Like, you know what I mean? Like, I take a lot of notes, and that's the issue. Who is... oh god, what is this? Something... If we cancel... Yeah. Let me see. Okay, you know what? This is not going to work out. this is why I moved over, because I just can't find stuff. Like, that's the issue. Okay. Oh, shoot. They needed them by noon today. Had a... I'll submit now. Okay, I need to actually submit some hours really quick. Oopsies, this should only take a second though. But yeah, really this is a lot of just data manipulation. I don't necessarily need to understand exactly what it means at this stage. I just need to make sure that yeah, I just need to make sure that I can run it. Which it shouldn't be that hard to set up. I know what needs to go into the program, Biodiverse, and it's something that I need to prep up anyways, so I'm not overly worried. Come on, there we go. Log me in. Gotta love Duo notification. God, I was up at 6 a.m. this morning for a presentation. Absolutely ridiculous. It was a fine presentation, but just waking up at 6, or waking up at 5, so I could be mentally awake to give a presentation, not doable. Hold on, I need to check my calendar. And it was last week that we had this. Okay, the 19th, Thursday. Okay, but yeah. So really what we're going to be doing is going into R and then messing with the results to get what I need. Okay, why is this not working? Cool. Done and done. Nice. Okay. Now let's figure this out. So I need to find Biodiverse GUI. Oh god, it's an application on my, I know I have it though. I definitely have it downloaded. Let's see if I put it into here. God, everything is such a mess right now. Did I not? I might just download it again anyways. I probably need to get the more up-to-date version. That's fine. I'm just going to download it so I can also show you everything. So this is the page. It's a GitHub page. So if we just download it, very easy program to use. Biodiverse also does way more than just Canopy, but it is a fantastic tool. Yeah, I guess I don't have it downloaded. So it can run a whole slew of different programs, and I just, God, I've been loving it so much. Okay, that was easy enough. It's now downloaded and installed. Yeah. Run anyways. Let's open up my R. So all of the fun stuff. So why do I have extra things open? Okay. And then here's the Biodiverse GUI. So what I need to do is I need to upload a base data, a matrix of presence-absence data, and a phylogenetic tree. So that should be pretty easy. I actually did see that I do have I do have a R script, Biodiverse Prep. Let's see what that... Looks like I was in the process of making it. Okay, there's nothing there. Let me see if there's a... Oh. Hold on. I have multiples. Here we go. Steps. Make a map, grid it, overlay species distributions, create a matrix, assign variables from grid to binary matrix. Okay, let's see. So these are all amphibian shape files. We subset them by Bleedoglossa. This is obviously just a test. Make sure they have a central progression. This is so out of date. Oh my god. Okay, so we just need a presence-absence matrix, which I have already made. So post hoc. Let's actually make a new script. Okay, our script, new. Okay, so this one is Biodiverse Prep. Okay, so what do we need? We need a phylogeny. We need a presence-absence matrix. And we need a... Actually, that might be it. Yep, that's it. Okay, so the phylogeny is super, super easy. In fact... Oh god, I just have so many things right now, and I'm so nervous about this, but I did save everything. So let's do this. So load in data. We should probably also add our libraries that we need. Library. Probably just tidyverse at this point. Okay, load in data, load, okay. Everything that is actually useful, I probably already have. Okay, so let's load in just the outputs of the data. I mean, because I already know what's... Yeah, like, if I have to rerun anything, it's not going to take much time at all, because I already know what to do. But yeah. Once the data just gets loaded in, there we go. So I have the beta, I have pick ed, and I have a pres-absence matrix. Yep. So the presence-absence matrix is already ready. I do need to add in a phylogeny. So what data set is that in? I mean, I guess I have this. I can load in that. Yeah. And let's also load this. Because this will give us the phylogeny that I'm using, as well as just some other stuff. And so if you're not familiar with what I'm doing here, I have saved all of the outputs of various steps of my pipeline to these R data files. This gives me the hydrobasin. Does not give me the... it does give me the phylogeny. Sick. Okay. Okay, so we need of hydrobasins and then presab of phyloregions. Cool. So, let's see here. Let me... Okay. How about we get it going... How about we make sure that we are running the data for the canopy with all of the hydrobasin units. So if we do write.csv, okay, wait. Let's go to the documentation for Biodiverse really quick. Okay, quick start guide. What does it say to use? I don't know why it's taken so long. Let's see. Come on. Come on, load up. Why is this going to... Okay, there we go. Okay. Using this guide, labels, groups, starting, open or input data, data structures. Here we go. Matrices. These are matrices of numeric values. Labels, groups. Okay. Base data, storage your spatial data, different species and their XY locations, a set of analysis parameters, and one or more outputs from cluster. Okay. One record per observation with separate columns for one or more labels, e.g. names such as in groups, X and Y coordinates. You can also import a matrix of data. Okay. So this would be like base data saying that the genus and the species are found in this XY coordinate. So this is just... Okay. I've done this before, so these are cell sizes. Now the thing is, the cells don't really matter in this case. So I think... Let me see the matrix. Okay. You should select at least one label column and only one matrix start column. What is this? So, column 35, ignore the labels or genus species, matrix starts there. The tree is easy. You can now import... Let's download the examples. Data structures. Okay, so groups are bins. So our groups would be... Okay, let's write all this down. Notion, 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 notion. Boom. Okay, canopy, data needed. Base data. Base data. Groups are the... Okay, groups are hydrobasin unit IDs. Labels. Okay, so labels are the species. Labels are species. There are coordinates, which is the center of the group. So what I need to do is for each hydrobasin unit, get the center of the group. Okay, I think. I think I only need this base data. Yeah, I think I only need this base data. So, base data, it's also allowed for element properties. Let's see. Remap changes name, method labels. You can also include or exclude or include. Okay. So, we're not just writing things out. So we have this presence-absence matrix right here, but this isn't exactly what we need. What we need to do is convert this oh, but they're all different sizes is the thing. Matrices. It's not really clear. Yeah, it's not really clear. Let's see, because I don't want to divide it up. That's the whole thing. I don't think area actually matters for this, though. So let's get the... Okay, so we need to get... Okay. So for every hydrobasin, what we can do is... We can get that. Let's see. Okay, we're going to need the SF package really quick, because we might actually already have this. Hold on. Library SF. Okay, so then st get or st geometry of hydrobasin. We'll get the first row. Okay, so it's a multi-polygon. So is there st center, st centroid, centroid of hydrobasin 1. Let's see. 0 point. Oh god. Okay, with 1 feature and 15 fields. Warning. Is there constant? Okay, yeah. So it gets a point. Okay. So what we're gonna do is we're gonna run this apply function. So let me actually see what this looks like. So if we do st centroid of hydrobasin 1. Okay, so test, so it shows up as a geometry, which makes sense. So if we do test geometry, okay, if we just do that. And then we get the... I want to get the x coordinate and the y coordinate. Although it looks like in the bounding box, we can get that. Okay, so maybe I can do at for this? No. Let me just see what happens if you do that. Wait. Let me do... let me just see. I'm just doing it like this. Easy enough. Okay, cool. So we're going to make a function, x, across x, we're going to do stcentroid, stcentroid of x, and then we need to take, let's just make this super, super easy. Oh god, what am I thinking? What we're going to do is we're going to mutate it. We're going to apply this function, stcentroid of that, which we'll then do the geometry. I don't even know if this is going to work. 1. Okay, so out, return out. So if we do fun... So if we do fun hydrobasin 1, and then fun hydrobasin 2, we get a different point. Nice. And so then if we do, okay, so if we have a new one, we're going to call this hydro xy. And then what we're going to do is we're going to take the hydrobasin. We're going to apply, or no, we're going to mutate. Mutate xy is equal to apply over that. We'll go by row, and we're going to do the function fun of that. I don't think that's right. Okay, just curious. Argument x is missing with no default. Oh god, I think this is it. No way this fucking works. Error. Ah. Oh. Boop. Boop. Error. Fun is not a function, character, or symbol. Function of x. Let me just... Object x not found. Okay, let me look up how to do an apply within a mutate. Apply within mutate. Is there another function that does it? Ah, here we go. I didn't know row-wise. That's a new one for me. Ooh. Nice, nice. And then over that, we will just do xy is equal to fun. I believe that's all we need to do. Oh god. Problem with mutate, column, xy must be size 1, not 2. Okay. You know what I can do? I can just do this. Fun 1. And then y is equal to fun 2. What essentially this is doing is it's going over, it's applying that function twice, so it's going to take twice as long, but it's only taking the first row, which is x, and then it's going to take the second entry, which is the y. So super, 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 super simple. And then I should just be able to import this as each HiBass ID, and then the xy. I'm pretty sure. think that's all I need to do. Let me double check. So, where was I? Okay, here we go. So X and Y, and then what we're going to do is we're going to just extract it out. We're going to remove the geometries altogether. And then we are going to add in genus and species to figure out which ones they're in. This is going to take a while. I know it's going to take a while, so whatever. So then we need to figure out how to convert this presence-absence matrix, which I think is actually going to be pretty dang easy. So if we convert... So, presence, absence, matrix to long. Oh, reshape. Forgot about that package. Look at that. But see, what I'm confused in is, like, I think I can just have this Hydra-base unit and then import the matrix. That's why I'm just, like, confused about the matrix thing. Because it's not very clear. One label column and only one matrix start. I'm thinking that's what I do. I do the label of... Well, there's two labels, right? You need a column of labels. Yeah, I think what I'm gonna have to do is then we're gonna have to create a new... Yeah, so this is gonna be the group. Did I even need to do this? At least one group. I might not even have to do this, honestly. Okay. Yeah, so I'm gonna have to figure out some way of converting this presence-absence matrix into the data I need. So I need to get the labels. I'm not gonna do genus species, I'm just gonna keep it that one label, make it very easy. So we add that on. Hey, Lufu, I'm doing good. I'm currently waiting on this analysis to, not even analysis, this data manipulation to finish running. I'm kind of trying to figure out this bit of a complex data structure with this one program. They're not... It's unintuitive, I think, to how data is typically structured, so... But, yeah, like, I'm not sure... And the documentation isn't ultra clear. I've done it before, but it's just, they say I can, like, import a matrix, but it's no clear idea about what the matrix is. Yeah, it's a little bit weird. So they need to share labels, but that's why I'm just confused. I wish... Maybe they have matrices representing some relationship between pairs of labels or groups. They are used for analyses of all the matrix structures linked by the matching labels in a base data. They are also used as part of a cluster analysis, in which they relate to pairs of groups in a base data. So it's matching labels. So maybe I can do that with this presence absence matrix. But I don't know if I can relate the groups to it. That's the thing. I think I know what to do with this, though. So basically, I have a ton of hydrobasin units. Just like where rivers and stuff are found, basically. And I have I'm getting right now what's running, I guess you can't see it, it's just stuck running because it's a big thing, is I'm trying to get the centroid of each of these hydrobasins. So just like where they are in the center. It's running, I'm pretty sure it's working, but there's like 16, almost 17,000 units, so it's just, a big data set. You only have to do it once, luckily, but still, it just, takes a while. But then I need to compare it to a presence-absence matrix, which that's what I'm trying to do. So I'm trying to convert a presence-absence matrix from wide to long. Wide to long in R. Let me see. It is gather. Okay. Maybe it is just gather. Okay, so the data object, the name of the new key column, made from names, name of the new value column. Oh, I see. Measurement. So they just said measurement. So this one is control to condition 2. So they have control to condition 2. This is definitely it. I need to do gather. Job, school. Oh yeah, this is for my master's research. So I'm trying to run this analysis called it's called categorical analysis of neo and paleo endemism, which I guess it's school and my job and my work and my research. They're all kind of interconnected, really. But yeah, it's this big, it's this really cool analysis that highlights areas that have like phylogenetic endemism. So like lineages that are unique to an area, but it categorizes them even more between like newer endemism versus older endemism, which just tells us a bunch of different things. So really what I'm trying to do is it's just data manipulation, because I have really good results already for a bunch of this. This is for the world's turtles, by the way, as well. So it's like I have this, which is if we go full screen on it, like these are all regions of shared evolutionary history. So what I'm trying to do is I'm trying to, within each region, figure out, is it full of neo-endemics or is it full of paleo-endemics? So old endemics or I guess new endemics or old endemics, if we're keeping the order consistent. And really the biggest challenge is just getting it set up for the program to figure it out. That's really the biggest challenge. So I got one part running, and it should be good at some point, but it's just, doing it out the next part. I think what I need to do is I need to take my presence-absence matrix, convert it to wide, and then merge it with this current data set that I have. So that's the key trick. But I'm pretty sure I would just be doing, long presab, and if we do it, it would be presab gather, and then we would do that. The key, I need to figure out this gather command more. Okay. Oh, use all the columns. Oh, okay. Yeah, I guess I'm confused by what they're doing here. Because they're using all of these columns for control through condition. Oh my god, I see it now. Okay, I see it now, I see it now. Yeah, so this is going to be super easy. Okay. So it would be presence absence, we would gather it. The names column would just be... Well, I guess I need to make it a... It's really just the names. So they're doing it by condition, which is the name of the new key column. Wait. Old data wide. The next one is the new key column. They're using condition. And then the values are found there. Okay. So what I need to do is then... Okay. Oh, wait, these are just the names, right? Oh, this is just the name. Okay. Okay, so how does it get sex into there? How does it do that? Because it's pulling that. It's pulling subject and sex. I think what it would just be is just hydrobasin, and then... Okay, and then just... Yeah, I'm in the U.S. I'm based in San Diego. So, yeah, I'm based in San Diego. That's really it. Yeah. So it's good. Where are you based out of right now? I'm not sure if you've tuned into a research stream before or not. I'm terrible with remembering usernames. But yeah. Treat the new key column as a factor. Yes, I do want to do that. Okay. Factor key equals true, and then this one I would just be using all of the columns, so it should be... Oh god, 6... How many zeros is in there? 10 through... Whatever's the last one. I would just need to do it. Oh my gosh, this centroid thing is just taking so long, though. I don't even think I need it. But I'm doing it, so... It's also going to populate with a ton of warning errors, and I'm just going to ignore all of them. Huh. Yeah, I'm kind of limited because I can't really do much until this is done running. The phylogeny is already there. I guess I can kind of... I'm basically trying to upload it into this program to run it. It's a very simple analysis, too. But I just need to put it in there. Oh, sick! That's a cool study. Wildlife protection and exploitation. Next year I'm going to try... Oh, I think I got cut off. Nice. Yeah. Oh, sick. Okay, yeah. A Canadian university, I'm assuming. I know a couple of them up there. I've had a few friends at McGill, I think. Surprisingly, a lot of anytime I'm like down doing research in Belize, there's a lot of students from Canada. The station there is owned by Canadians, so that's probably why. But yeah, there's some really good ecology schools up there too. I've been kind of jealous sometimes. Man, because it's also cheaper. Yeah, and I've only recently started doing the streams here. For about a month or so, I was trying it on Twitch, and basically I'd have nobody come in. So it was like, I don't know. I guess because like you're not gaming, and so you have to go into like just chatting or whatever, and way too many people doing that. So YouTube, I actually get random people coming in, and that's what I kind of want. Concordia. Okay, yeah. I've heard McGill's pretty intense, you know, which I get. Like, I know it's one of the big universities up there, but let's look into this spatial index while I'm basically just waiting on this to run. Ooh, wait. Oh, there's supposed to be a thing. Oh, hey, man, what's up? Got 2 people in there. That might be a new record. No, the next video will look like this. No. Oh my god, I don't even think I need to do this. Hold on. I don't think I need to do this. I think I could just import it. It might suck, but I think I could just import this. Okay, I'm gonna stop it and see. One, I don't even know if this was working. Okay, so if I write .csv, then I might not have to do anything. I'll probably need to revisit this, but write.csv, what I want to do it is the pres ab, and then file, yeah, is equal to outputs, pres ab k61.csv. Oh my gosh. If I don't have to do this, that would just be a... That's what I thought. I don't remember actually doing that much data manipulation. So matrices import. Let's see here. So this is in my Google Drive. But yeah, how you doing, man? I've been... Gosh, I don't know where this week has gone. It's been a long day. Where am I? Oh, right. OneDrive, research, Phylo region, Phi global turtles, outputs, presab k61. Okay. Input file format. It's a normal matrix. Okay. Select column types. Okay. So this is a matrix start. I don't have the labels. If I just do this, will that work? Ah, no, it doesn't work. Okay, hold on. But maybe I import it. I remember this being really weird. And also just this whole thing, like, always starting at the... You always gotta start it way back, and it's kind of frustrating to use. It doesn't have memory of where you just were. So, let's see. Yeah. R is really helpful. I love it. I really use it a lot. But I'm actually developing an R course right now for biologists specifically. It's in very early stages though. It's meant for next semester. But yeah, it's worthwhile. I think it's helped me a whole lot. But okay, let's see this. So type groups, label start column. Let's just see what this does. I think I might have mixed it up. Non-numeric group field. Okay, well that's fine. I might need to transpose this. So let's just transpose it as we write it. That'll make this a little bit easier. Okay. But yeah, R is a really useful programming language, and it can do a lot. It could do a lot. Recently used. That's just not true. It's not true. Google Drive, okay. It's actually not that difficult. It just has some peculiarities to it that can make it a little bit difficult. But I think the biggest thing is that a lot of the courses teach it for a very general audience, and that's not necessarily the best. Okay, there we go. So this one would be groups, and then this one would be label start column. Oh my god, is it loading in? Yeah. Definitely look up some R for Dummies courses, and there's some really, really good, there are some really good, like, oh god, what is it, like, kind of like online courses that are pretty useful for just helping you learn the actual language. There's just not that many that are specifically focused on, for biologists, that aren't already paid or whatnot. So I'm trying to do one that's a little bit, easier. A little bit easier. Okay, let's see. Mystery, no. OneDrive, research. But yeah, I mean, even knowing the fundamentals will help you out a ton. I've been teaching, for the last 2 or 3 years, teaching this biostatistics course that is entirely run in R. And it is so helpful for the students. They really do. It really sets them up, is kind of the thing. So why is it showing up like this? It should just be a Nexus file. I'm doing the Newick tree. Yep, this one. I don't know if it'll import though. That's not it. Okay, wait. Okay. Trees, import. No, not tabular. Okay, here we go. Now it'll work out. Okay, Google Drive. Ooh, this makes me so happy if I don't really have to do anything. I was hoping to get this done today, actually, so this is going to be nice. I have a meeting at 3, so that's kind of my hard cutoff of figuring this one out. Research, Phylogenetic Endemism. Nope, wrong one. Phi Global Turtles. Inputs. There we go. Remap the node names. I'm going to hit no for now. So if I have these two... Yeah! Oh. The names are messed up between the two. One has an underscore, one has a period. Okay, time to... Let's do this. I believe its name's Prezab. No. Row names? Yeah. So what we're gonna do is we're gonna look at that, and then row name, we're gonna G sub over, we're going to do boom, boom, and then we're gonna do that over the names, or row names. Yeah, so like this is R, like we were just saying. It allows you to do a whole lot, so everything from plotting really, really nice graphics to actually analyzing the data and manipulating it. So now that we have that, I just need to reload the base data once this is done writing to file. All I did just now is I replaced all of the periods to underscores within the data set, so now that it'll map properly. So let's delete that, do a new one. And then, I don't know why I can't just go to the recently opened spot. That would just make things so much easier. Okay. Boom. 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 Outputs. Boom. Yeah. Okay, data are in matrix form. Okay. Oh no, I messed it up. Oh no. Oh my gosh, I forgot that you need to add that. Oh god, I gotta reload the data really quick. Okay, I gotta reload the data. Basically what happened is the period is a unique search character that means any character. So I think I needed to put, is it 2 forward slashes? No, that's not it. It's 1. Okay, that also messed up. Luckily, it's pretty easy. I actually don't even need I'll keep that just in case I do need it. Maybe it's a /. It's just now in a different format, so I'm very confused. And I don't know if it worked or not. Oh, okay, but it didn't do it. Wait, maybe I did have it right the first time and I'm just being stupid. Let's see. Oh, perfect. Yeah, we did have it right the first time. Okay, cool. Now I can write it to file. Then cancel. Cool. Super easy. Let's... Okay. Open object. Or no, I think I need to do import. Okay. Google Drive. There we go. Let's open this up. Just gonna move the chat window a little bit over so I don't have to look all the way across. Research, Phylogenetic SDSU, faculty outputs, boom, next, state R in matrix form. Cool. These are the groups, and then these are the labels. Okay. Okay. Cool beans. I think it should work now. Remap the label names. I don't think I need to, but yeah, so if we open this up, yeah, it's all mapping properly. So yeah, now look, whenever I click on something, it'll highlight it in that phylogeny about where it's at. So this is perfect. Can I just run this? Can I just run it? Oh god, yeah, there's a whole thing about how to do this. So I think I want to get Phylogenetic Endemism. I'm just going to run one. Okay, so I think there's a thing where I need to create tree from labels first. Wow, that is not what I wanted to do. What I'm trying to do is I'm trying to subset it so that it only has... Okay, tree? No, okay, we're gonna change out the tree. Anonymous 0. This one I'm gonna delete. Yes, that one. So tree. And what we're gonna do is we're going to trim it to match base data, because there's just a couple groups that aren't found on there. And I don't think there's any groups in here, but just for the sake of it, we're just gonna trim to match tree nodes. Okay, yes, there were a couple. So now if we do it, Spatial Endemism. Wait, no. Phylogenetic Endemism. Let's see. Dang it! Can't use string. Let's just see if it's that particular analysis. And let's just run it with... I remember this thing being just a little bit weird. Okay, so let's do species richness. So that ran. I wonder if it's because I don't have a matrix. View. Yep, this is being weird. Okay, well. but it doesn't really have... The issue is that it doesn't have any spatial coordinates, so I don't even know if it would show it. I want to be able to make a matrix. No. Is that what that does? I don't even know if that did anything. So I can convert the tree to a matrix. How do I convert the base data to a matrix? Unless I just completely misunderstand. Let's just see what this does. I just want to see what it does for the matrix. Because maybe I misunderstand how to use the matrix. Oh, okay. Oh yeah, no, that makes sense of why we're doing this. Okay. So then... No, it's making it... It's doing some weird comparison. I don't think that's exactly what I wanted. Oh god, it's a little bit... Okay, I see. So it's comparing the two species to one another, which isn't really what I wanted. But let's do none. I do want to do some spatial analyses, though. So let's say... Okay, let's do NRI and... No. Let's see. Phylogenetic indices. Let's just do a simple evolutionary distinctiveness per site. GUI. Oh, so that works. The problem is I don't actually have cells. Wait, let's just export this really quick. Export this as a delimited text file. List to do it in. Let's do it in desktop. Test. Because I'm not actually sure what it even looks like. Okay. Okay, open with, let's open this up with Sublime and look at it just a little bit more. Okay, so it is showing it in each element. That's exactly what I wanted. Yeah, this is exactly what I wanted. Except, why only 70? Wait. Yeah, why only 70? Why is it only showing 70, though? Okay, wait, let's just close out of all of these really quick. Oh no, it's also giving me errors. So it is able to pull each of these. We can see that... Okay. Yes, we can get an output. I don't know why it's not giving me phylogenetic endemism, though. Why does it give me only that? So if I look at the console output, can't use this string as a hash reference, while strict refs in use. Let's say that, why is this crashing on me? It's never done this before. Come on, don't crash on me. Thought it was working. Oh gosh. While this is struggling, let's see. So the guy who made this also is the one who did Canopy. So let's look up the Canopy analysis and see what I need to do. I have this page bookmarked. Okay. This guy also has a Biodiverse R pipeline. Let's see how this works out. Oh, where is my music? Yes. There we go. Why is that the pipeline? What is this? This is useless. Oh my god. Okay. R release. I'm not even going to use this because that's not exactly what I need. Okay. This is just being very odd. Okay, so I know that there is a way to do it, and I've found it before. March, publications. No. Yep, so you randomize it. Calculate a bunch of stuff. Okay, here we go. Okay, so we gotta view the data. Yep. Spatial, okay. Okay, so let's close this really quick. Close it really quick, yeah. And then just see. Oh gosh, it's always some weird issue. I don't think it's gonna work though. Why don't you why doesn't recently used work? Ah, so annoying. Google Drive, okay. Okay, data are in matrix form. Okay, so then this is Oh, it's a text grouping. Maybe that's the issue that I had. Label start column. Okay. Okay. Maybe that was the issue. Maybe because I did choose groups that were spatial, but it's not spatial. Okay, boom, tree. We're going to add this in. Nope, not a tabular tree. Let's get this in here. Inputs, Newick tree. Okay, cool. Okay. Nope. Okay, so tree. So we're going to trim to match base data. Okay. And then base data, trim to match tree nodes. Okay. Cool. So we have them in there, and it says go to analyses, go to spatial. Okay. Ooh. Make sure the tree you want to use is selected. That is true. Okay. We only understand each group cell in isolation, not collections of groups, so we need to delete the second spatial condition. I think that's what I already have. It's like the phylogenetic endemism calculation. This can be accessed underneath the phylogenetic endemism category. Okay, looks like that's already been changed. Phylogenetic endemism. This can be assessed. Fetching C's. Then select the relative phylogenetic endemism type 2 underneath phylogenetic indices relative. Phylogenetic endemism type 2. Okay. Okay. When it is all selected, hit the go button. Oh, it worked! Oh, sick! Set. Oh, okay, display results, yes. Oh, cool, it does make grid cells if you do it as text. Or maybe not. Okay. Okay, we don't need to do this. This is fine. To assess which of the cells are candidates for paleo or neo-endemism, we need to run a randomization. In this case, we select the random structured option in Biodiverse, constraining the richness of each group cell to be equal across all randomizations. Okay, so what is this in analyses, in randomization? Okay, yeah, so we use rand structure. We'll use 999 iterations, with all the results being prefixed canopy. Okay. The base data will be saved at any iteration. Okay. Edit the checkpoints Christian memory leaks. The parameter section allows. In this case, we will leave the trees alone. I don't think we would do anything. We have no group properties set, so we can leave randomized group properties. Okay. A richness multiplier of 1, richness multiplier, and a richness addition of 0 means we're up to the exact scores. Okay. Now we hit go. Oof. Okay, so this might take a while. This is going to take a while. Okay. So it's done 2 of 999. 3. Yes, this is going to take a few hours for sure. But hey, it's working. It's so easy. I love Biodiverse so much. I'm excited because my advisor talked about doing this last week. And I was like, yeah, I can do it. And here I am. It's been like an hour. Just needs to run. And then we'll just have to categorize the results and visualize them all. But I also do want to run this. I should have run this per phylor region first, and then I'm not sure how to make this work out. So what we will do though is I also need to check Discord because I have a lot of messages I need to look at really quick. Hold on, I don't think I should be showing these because there's some back end stuff. Looks good to me. Cool. Yeah, so that little short film competition, film festival, I decided to stop making it a competition. We actually decided to not even vote at all. We're going to be showing off all of the films this Saturday at noon Pacific time. And so it's... Oh, I'm so excited. Hold on, I need to minimize... Yes. But yeah, I'm super excited for this. Seed shop. Okay, we should come up with golden pigeon. Do you have any input here? It's just for fun items. I'm thinking 1,000 seeds should be about $1 in value if you're completing. Okay, we're doing so much stuff on the back end with mammals right now, and it's like, ooh, giveaways. You can like, retweet, and comment on this thread on Twitter, and then prove their action. Worth of daily claims. Okay. Nature lovers, science geeks. Wow. Okay. I need to mute channel until I turn it back on. And bounty proofs. Oh my gosh, we're just... Yeah, I'm super happy with all this, though. So this is just going to keep running for a bit. It actually might not take, like, hours and hours and hours and hours. It might just take a little bit of time. But, it'll take a couple hours, I think, at the speed it's going. But I should have results by the end of the day, so... Maybe we can work on some other things. It's probably going to be done right when I have that meeting that I need to hop off on. Oh, yeah, I'm just doing this in a stupid way. There we go. Mammals, text, logo, signed wild, propaganda. Okay. Awesome. For this first oh, this is so cool. Oh, but the emoji I guess I should have done this with just fewer randomizations to start off with, just to get an idea, but if I can run it for $999 now. Let's write up everything within Notion so I have it all. Is it in here? No. Okay. We have it here. There we go. Okay. Look at this. Canopy, category analysis, data needed, base data. Okay. So relevant materials. Yes. So relevant materials. I'm going to embed... I want to just view this page. Do it yourself canopy. There we go. I don't know if it's canopy or canape. So canopy makes more sense though. But it definitely is pronounced or spelled canape. So we're going to embed this into Notion. Okay, embed. And then boom. Okay. So followed the methods found on the DIY canopy blog post from Biodiverse embedded below. Data needed. Nice. Oh, I have like 75 things going on today, and it's just a little bit difficult to keep track of everything. Actually might finish a little bit faster than I realized. Maybe an hour. Oh, you know what? I actually do need to read the this turtle paper and take some notes, and maybe that's a good thing to do while this is running. Oh God, who all is talking to me? Oh, that guy's cool. Need for Speedo. I bought myself an ocarina a while back for no reason other than I watched Pokemon 2000 and just loved it, and I just needed it. And it's so stupid. It's the stupidest thing I ever did. I love this. The best part about social media is just the amount of people who send me frog pictures throughout the day. Oh, that's right. Let me just post this. To add. Petition to call it Zilfat. Okay, so let me add a link then, and now I need to go. Oh, I need some way to like store links on my phone a lot easier. This is not working out. I have so many links that I need to just keep sending, like the same consistent ones. Why do I have 1,000 Discord notifications? What the hell? Invite copied. If you want to submit your own, still time. Cool. Oh, I'm so excited for this. My short film is so bad. It's so good bad. Oh, it's so good bad. Oh God. Okay, I don't want this. Oh, let's go to Twitter really quick. Oh, no, I want to see that progress going. Swing. Okay, let's get here. Boom. 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 Yeah, it's actually running a little bit faster than I thought. Save tweet. Oh, here we go. I think it's really just going to be making some visualizations. That's going to be the biggest part of this, I believe. Because that's when we'll really get to see some things. I think, though, the only thing I'm wondering about with these canopy things is, does it matter if they're at this lowest base unit or not? Or can they also, like, if I run it instead of over all 16,000 grid cells or whatever, I instead ran it for over all 60 phyloregions, will that change things? And I'm really struggling to understand how the data would come out, because you're grouping the data in a different way. So that's the only thing I'm thinking about right now, and I'm not exactly sure. But because they might just show up all as mixed data sets, but maybe not actually. Okay, why don't we figure that out? So in R, let's get this. How could I set this up? So I need to make a presence absence matrix for, yeah, presence absence matrix for each phyloregion. Which, did I have that? Do I have that post hoc? Okay. No. Like, I wonder if I made that. Oh. Do I have that already? Oh my god, is that Rasp Western Hemi? Wait, do I already have this made? Let me look at my stuff. OneDrive, research, Phyloregion SDSU, blah, 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 outputs. So I would be looking at Rasp Western Hemi. Hold on. Okay, so this is in... Almost, actually. Hold on. I mean, it probably won't be that difficult to really do. I'm just gonna... Yeah, okay, it's not directly in that, so let's just make that here. Okay, well, now that I know I don't need to do all the Centroid BS stuff, that means I can delete all of this. Okay. Cool. Nice. So then I have my clusters. These are all within PicEd. PicEd, this one. We know which grid cells they're in. But what I need to do is I need to get it to where within each cluster it shows... Okay. So it's within each cluster what species are present there. What I think I can do... I'm trying to think about this. So... So, presab matrix of species by grid cell. By hydro. By cluster. There we go. So, okay, so first we're gonna make the matrix. So we're gonna do it as matrix. No, we're going to do this as a data frame. Okay. First, because I just think data frames are a lot easier to work with. Okay, so data frames. So we have the... No, we do want to do it as a matrix. Matrix data equals see names of, oops, pick ed membership grids. Okay, I don't need names actually. And then what I can do is then do pick ed membership cluster. And so this would be unique, because then this will only pull the unique values that are in pick ed. And this also means that if I rerun it at a future date, I believe this is it. So we're going to call this Matt. And I don't think this is what I wanted. No, this is not what I wanted. Okay. Let's see. Matrix are row names and call names. So, okay, wait. R create matrix from 2 columns. Multiple column vectors. Yeah. So I want to do something like this. Use cbind to produce the desired matrix. That's not what I want to do. I think okay, is it kind of weird? Yeah. Okay, so all of the matrix will be so that's why. Okay. So let's do it. Mat is a matrix where n rows are equal to, we're gonna do this, the okay, so we'll do length of pick ed. Oh wait, yeah, I'm not doing it by grid cells, I'm doing it by species. So the rows would be the species in presab, which I think is just names of row names presab. Yeah, row names presab is equal to length of row names presab, and then the number of columns is equal to length of unique values of pick ed membership cluster. And so that should give us a matrix of 356 by 61. Nice. Cool. So now row names of Matt are going to be equal to row names presab, and then the call names of Matt are going to be equal to unique of this. Cool. So now if I open up the matrix, we have each region, each cluster with that species. Okay. So now what I want to do is I want to look up for every species. So we're going to do apply it. I'm actually just going to do this as a for loop because I suck with the apply stuff. For I in 1 through row names Matt. Actually, I don't know why I'm doing this. N row Matt. This is saying that for, I'm going to go through every single row in the matrix. And then what I need to do is I need to look it up in presence absence. Okay. So first what we're going to do is we're going to extract from presab. Okay. So then extract, we're just going to call this row is equal to presab where the row names of presab are equal to row names mat the first row. Will that work? Numeric empty. Let's do I equal to 1. And still getting an empty. Okay. Oh. And I want all columns. So let's see this. This shouldn't be a row. It should just be a vector technically, but it's organized. Okay, so that's almost working. I'm getting all the columns. But I need to get... Oh, which... No. Okay. In which the row names of presab are equal to the row names. Ah, that's the issue. Okay, so maybe it's just... But is it maybe just names? No. Okay, wait. So if I do that, right, which is fine. Ah, so that's not it. So row names. That's what I thought it would do, though. But that's why I'm... So it's getting null. So wait. Row names mat. Oh. Row names mat I. That'll get the first one. Okay, and then boom, now I have a row that is a... I think this is it. View row. X. I'm just not sure if it's gotten everything. It looks like it might have. But it hasn't. Okay. So I just want to extract it out. Okay, wait, did this work? Okay, so boom, is that one. Oh my god, it might not be. Oh wait, no, they're both underscored. So we should be getting that first row of presab. Did I fuck up something? Let me look at presab really quick. Wait. Shit. Did I fuck up my presence absence matrix? No? No? Okay, it's showing up. I didn't fuck it up. Oh, no. Okay, yeah, it's just not showing everything because most of them are empty. Duh. Okay, so it's working there. Okay, cool. So we're pulling out the row. Now, this row shows all of them that they're found in. So what we're going to do is we're then going to make sure we subset this row, filter where oh god, where that is greater than 0. No, this isn't. Okay, I think we won't do this in a tidy format. So row is equal to row, which row is greater than 0. And so this gives me just 37. And then let me just make sure it has. Still got the row names. Okay, cool. Nice. So now what I need to do is then pull out which clusters this is found in. And I can do that. So then I will filter out pick ed membership by which pick ed membership grids are in the row names of row. So we're going to take out pick ed membership, and we're going to only keep the rows in which pick ed membership, the grids, is in. Okay, does row names of row work? That doesn't work. I don't know why row names doesn't always work. It's very odd. Okay, the names row. Oh, that works. Okay, so now we'll get the clust is the unique unique in which it is in cluster. Unexpected. Oh. Boom. So this clust now just has the thing. Okay, so now that we're still on the first row of mat, what we're gonna then do is over that first row of mat. So what we're gonna do is mat. Okay, no. So we'll now do a for loop because I'm just being lazy. For one n through n call mat, so that's for every column of mat, we'll then add an if statement. If mat j, so if that column so let's just say j is equal to 2. Let's see this. If we get this to be error names, it might have to be call names. No. Call names. Hot Aspidarities turtle? Is Alex watching my stream? Oh, Cactus Quoll just showed up. somewhere and it just can't find them. Okay, weird. Okay, so why is this not working? So what is it? What is the thing for? You know what? Actually, this is just increasing in order. I don't need to do the names. So if... Okay, wait. If J is in clust, then what we're going to do is we're going to say that mat ij is equal to 1. Now we will add in, oh god, else mat ij is equal to 0. I think this is perfect. Let's check mat. Oh no, it's a bunch of NAs. No, it's a bunch of NAs. Did clust change? Wait, did clust change maybe? Clust did change. Okay, if J... Okay, let's just run if J in clust. No, J in clust, false. Oh my god, I'm dumb. There we go. That'll fix it. And now we have a presence-absence matrix. By cluster. I love doing stuff in R. Oh, that's not too bad of a function at all. And then, okay. So now we are just going to save mat as file equals outputs / species by clust mat.csv. Oh god, what did I do wrong? Wait, what did I do wrong? Oh, do it save. It's not the right function. Write.csv. Cannot open. What do you mean? Okay, I don't care about that. It be doing the randomization. Yeah, let's see where we're at. Oh, we're like halfway done. We're over halfway done. Yes. Heck yeah. Mm-hmm. Sick. At IBT local 20. At IBT 20. And then just clapping emojis. Clapping emojis. Clapping emojis. This is so good. This is actually running so fast. Wow. Oh, I got some mentions I need to respond to. Oh my gosh. Oh yeah, hey, you too. Thanks for joining in. I always like it when there's somebody in the stream. Let's see. This one is going. Okay, I think I need to start hopping on more. Okay. Let's see. God, I got so many things I need to look at. Jesus Christ. I've gained like 1,000 followers in a week. Ooh. Ooh, I might be able to do 90-second long reels now. Oh, I can do 90-second reels! Oh, this makes me so happy. Oh, this makes me so happy. Okay, so. I'm gonna film a reel. I'm gonna do this right now. Cool. Have you ever heard of categorical analysis of neo and paleo endemism? Yeah, not many people have. But I just got 90-second reels, so let's talk about them. Have you ever heard of categorical analysis of neo and paleo endemism? Yeah, not many people have. But I just got 90-second reels, so let's talk about them. Have you? Okay. But I just got 90-second reels, so let's talk about this really cool methodology. Let's just hide that. This is my nerdy post of the day, oh my god. Because I'm actually running it right now. So, Canopy, otherwise known as Categorical Analysis of Neo and Paleo Endemism, is a... Okay, I need to actually figure out what I was gonna say. Oh god. Okay, wait, let's open up this link. Okay, I want to just have a really, really good okay. Because I am actually running that cannot speak. Y'all are seeing how many times I mess up now on this. I am actually running this analysis right now. Nope. Okay, now I know what to do. I am actually running this analysis right now, and again, it is Canopy, Categorical Analysis of Neo and Paleo Endemism. What this methodology allows us to do is uncover areas of old and new phylogenetic endemism. But Dylan, what does that mean? I'm glad you asked. Okay, so this is so weird. I don't know why I'm doing it like this, but screw it. There was one definition of phylogenetic endemism. First, let's take a step back. Phylogenetic endemism, basically, I just need like a quick definition of this. This is literally why I do so much science communication, because I'm just waiting on stuff to run. Phylogenetic endemism describes to the extent which unique phylogenetic lineages are geographically restricted to a particular area. Now, this is very context specific. For example, every organism... No, okay. No. Now, of course, endemism is very context specific. For example, every single organism on Earth is endemic to Earth. We are found nowhere else. And certain groups of organisms, such as boa constrictors, no. But within every group of organism, they can be geographically restricted to a particular area. For example, tuataras are only found in New Zealand. Oh, this is so good. I can finally like really get in depth. Okay. New Zealand. Restricted to the New World. I feel like I should be adding in something. Have you ever heard of I am actually running this analysis right now, and again, it is Canopy, Categorical Analysis of Neo and Paleo Endemism. What this methodology allows us to do is uncover areas of old and new phylogenetic endemism. But Dylan, what does that mean? But I'm glad you asked. Phylogenetic endemism describes to the extent which unique phylogenetic lineages are geographically restricted to a particular area. Okay. Now, of course, endemism is very context specific. For example, every single organism on Earth. Now, of course, but phylogenetic endemism describes to the extent which unique phylogenetic lineages are geographically restricted to a particular area. Now, of course, okay, we're going to delete these. Describes to the extent which unique phylogenetic lineages are geographically restricted to a particular area. Phylogenetic endemism describes to the extent... Okay. Have you ever heard of Okay, let's do... green screen, green screen, green screen, making this look all nice and purty. Okay, boom. Essentially, this is saying which groups of organisms that are constrained on a phylogeny, where are they found? Such as this purple clade is only found in this area, kind of northern Mexico? Yeah. Discard that. Essentially, it's saying which clades of organisms are only found in a particular area, such as this purple clade only being found in northern Mexico, and it looks like the Caribbean. That's phylogenetic endemism. It just describes how much of that. Okay, I'm just gonna crop that up. Have you ever heard of categorical? Essentially, it's saying which clades of organisms are only found in a particular area, such as this purple clade only being found in northern Mexico, and it looks like the Caribbean. Looks like the Caribbean. Looks like the Caribbean. Have you ever heard of category? Essentially, it's saying which clades of organisms are only found in a particular area, such as this purple clade. Have you ever heard of categorical analysis of Neo and Paleo Endemism? But I just got 90-second reels, so let's talk about this really cool method. Have you ever heard of categorical analysis of Neo and Paleo Endemism? But I deleted a clip. Oopsies. Okay. Have you ever heard of categorical analysis of Neo and Paleo Endemism? Okay. Don't worry, most people haven't. Ooh, I can edit on a picture of canopy. Let me do. Yeah, this is. Okay. Oh my god, this is an Instagram experience I'm not used to. It seems to be working not buggy at all. Add media. This is weird. Okay, let's do this. Okay. Don't worry, most people haven't. That's kind of the clickbait thing. Have you ever heard of categorical analysis of Neo and Paleo Endemism? But I just got. Okay. Oh, I need to switch it around. Have you ever heard of categorical analysis? Done. Have you ever heard of categorical analysis of Neo and Paleo Endemism? Don't worry, most people haven't. But I just got 90-second reels, so let's talk about this really cool methodology. I am actually running this analysis right now, and again, it is Canopy, Categorical Analysis of Neo and Paleo Endemism. What this methodology allows us to do is uncover areas of old and new phylogenetic endemism. But Dylan, what does that mean? I'm glad you asked. Phylogenetic endemism describes to the extent which unique phylogenetic lineages are geographically restricted to a particular area. Essentially, it's saying which clades of organisms are only found in a... Have you ever heard of category... But it also adds on... Nope, okay. Yeah, I need to process live. Clip. Now we can actually extend this methodology. We can actually extend this further by talking about Neo and Paleo Endemism. New and old. Okay, little bit. Neo and Paleo Endemism. I'm just trying to find like a definition. Essentially, neo-endemism is a... Okay. And then, I'll try to find this. Neo and Paleo Endemism. I know there's a figure I can use that works really well. There we go. Wait. No. I think. Ooh. Wait. No. I have a figure for this, and it's just not working. I just can't find it. Okay. Let's do a reveal background. Let's make this fancy. If we look at Neo and Paleo Endemism, like here, did it work? No, it didn't. You bitch. Wait. Have you ever heard of categorical analysis of Neo? Yeah, wait. Okay, wait. Oh, okay, I see it now. Discard latest clip. Okay. So if we look at this methodology of categorical analysis of Neo, why? Oh, do I need to do it hands-free? Okay. Let me see. Essentially, the difference is that neo-endemics are endemics because they are relatively new species on the taxonomy. They kind of look like they're clustered together here. Have you ever heard of categorical? Essentially, the difference is that neo-endemics look like they're clustered together here. They're clustered together here. Have you ever? Essentially, the difference. Have you? Paleoendemics, on the other hand, are typically older lineages on a phylogeny that are geographically restricted because of range reductions or extinctions along the phylogeny. Paleoendemics are instead typically older lineages that have a range restriction due to extinction or range reduction through time. Kind of like these here. Let's get this almost done. This is so stupid. Canopy allows us to look at these. Canopy allows us to discover these regions that have very high diversity, but. No. Canopy allows us to uncover the regions of high paleo or neo-endemism. These areas are of conservation concern because neo-endemics are. Yep. Canopy allows us to uncover these areas of category. Canopy allows us to uncover the areas of high neo and paleo endemism because these endemics are of conservation concern. What do you think about this method? Sources are in the comments. What do you think of this method? Sources are in the caption. Have you ever heard of categorical analysis of neo and paleo endemism? Don't worry, most people haven't. But I just got 90-second reels, so let's talk about this really cool methodology. I am actually running this analysis right now, and again, it is Canopy, Categorical Analysis of Neo and Paleo Endemism. What this methodology allows us to do is uncover areas of... Have you ever heard of categorical analysis of neo and paleo endemism? Don't worry, most people haven't. But I just got 90-second reels, so let's talk about this really cool methodology. I am actually running this analysis right now, and again, it is Canopy, Categorical Analysis of Neo and Paleo Endemism. What this methodology allows us to do is uncover areas Instagram fixed a lot of bugs. New phylogenetic endemism. But Dylan, what does that mean? I'm glad you asked. Phylogenetic endemism describes to the extent which unique phylogenetic lineages are geographically restricted to a particular area. Essentially, it's saying which clades of organisms are only found in a particular area, such as this purple clade only being found in northern Mexico and it looks like the Caribbean. We can actually extend this further by talking about neo and paleo endemism, new and old. Essentially, the difference is that neo-endemics are endemics because they are relatively new species on the taxonomy. They kind of look like they're clustered together here. Paleo-endemics are instead typically older lineages that have a range restriction due to extinction or range reduction through time. Kind of like these here. Canopy allows us to uncover the areas of high neo and paleo endemism because these endemics are of conservation concern. What do you think of this method? Sources are in the caption. Have you ever heard of categorical analysis of neo and paleo endemism? Don't worry, people haven't. But I just got 90-second reels, so let's talk about this really cool methodology. I am I'm using the software Biodiverse to run it. Seriously, an incredible analysis. Canopy. Canopy. Can be found from Mishler et al. 2014. Canopy. And on the Biodiverse blog. And on the Biodiverse blog. I am currently running it for the world's turtles to uncover areas of the world's turtles to uncover areas of this endemism. This area. Regions of key conservation concern. Based on their evolutionary history. This is probably the deepest post I have ever done. Science, communication, evolutionary biology, biogeography, and then phylogenetics. Oh god, this is probably the most I have ever done. Jesus, okay. Okay, let's get it covered. I'm trying to get. This is, it's so much fun whenever I just make something that I just kind of like, even though I know it's not going to do any good. Oh my gosh. It's also my caffeine is hitting. What is Canopy? Okay, boom. Oh, we almost got the results. I don't see how this could possibly be messed up. So, rename audio. Share.
30,000.
30,000.
30,000. 30,000.
Have you ever heard of categorical analysis of Neo and Paleo Endemism? Don't worry, most people haven't. But I just got 90-second reels, so let's talk about this really cool methodology. I am actually running this analysis right now, and again, it is Canopy, categorical analysis of. Have you ever heard of categorical analysis of Neo and Paleo Endemism? Don't worry, most people haven't. But I just got 90-second reels, so let's talk about this really cool methodology. I am actually running this analysis right now, and again, it is Canopy, categorical analysis. Have you ever heard of categorical analysis of Neo and Paleo Endemism? Don't worry, most people haven't. But I just got 90-second reels, so let's talk about this really cool methodology. I am actually running this analysis right now, and again, it is Canopy, categorical analysis.
Caption's still broken though. Look at that.
Don't worry, most people haven't. But I just got 90-second reels, so let's talk about Neo and Paleo Endemism.
What does it mean if someone sends you a waving emoji and I think of this emoji? Like, I don't know what this means. I don't know what this means. I don't know what that means. I'm just gonna ignore it. I don't know how to respond to something. I'm like, I'm just gonna ignore it because I am a child. Okay. Okay, no, don't care, don't care, don't care. Oh my gosh, we're so close. I should have worked on a script to visualize this, but whatever. Ooh. Where is the blog that is talking about this particular, like the, oh, I have that in my Notion, not in the blog. That's right. Run the spatial analyses. Okay, yep, that's running. The randomizations. Okay. This is another case of the images are in the previous blog post. Look for step 2. And so basically, once I have these outputted, I just need to plug them back into R, and then I can plot them according to per a hydrobasin. Per hydrobasin, yeah, I can just plot it in ggplot with a fill equal to the value, I guess. Oof. Okay, well, it looks like we also need to do some classification. Oh, God. Come on. Oh, gosh. Is it time for a... It's only 2 o'clock. I am kicking ass today. Hell yeah. Okay. But yeah, I will have to shut off the stream at 3, or at least go paused for a little bit while I take a phone call.
I am actually going to stop the stream now. I realized I have not eaten today. So thank you for joining. We'll show some results at a different stream. Thanks.